Howdy folks, welcome to episode 2 of my GitHub Copilot video series. In the first episode, I explain what GitHub Copilot is and how to get started with it. Be sure to check it out if you don't have VS Code or GitHub Copilot set up yet. Today, I'm going to deep dive right into using GitHub Copilot in agent mode to help me jumpstart building a solution to help me operate my real estate business, as well as share my take on NVIDIA CEO Jensen Huang's claim that with AI, everyone is now a programmer. Will that actually hold water though? We'll find out. But let's be honest, this video is long, and although I'll be sharing key takeaways scattered throughout the entire video, if you are short in time, please use the chapters in the description to jump throughout the various sections of the video. To set some context real quick, I've been operating my real estate business for 7 years, self-managing and operating my properties. And as I've mentioned in previous videos, I heavily rely on apartments.com for everything from processing applications, rent and bill collections, maintenance requests, and tax preparation. However, there are features missing that I've shared with apartments.com directly, but unfortunately haven't been implemented. The top two are the ability for a homeowner to delegate the management of the property to one or more property managers, each with their own account. Today, only one account can be used per property. This doesn't scale well, as I'd have to share my username and password with others. Not good. So, a feature would be to enable the ability to track the entire maintenance request lifecycle and enable communication between all parties directly with the website. With that, let's jump right where we left off from episode 1 and begin using GitHub Copilot in agent mode to help me build this exact solution. What you see here is the output of a lot of work and time. I wrote around 164 lines outlining the various sections: technical requirements, user personas, key components, and functional requirements. Each of these sections conveys the solution's purpose, preferences around technology stack and engineering fundamentals, as well as all of the features it needs to support. This brings me to my first key takeaway. Using AI does not replace deep domain expertise and technical expertise. I've used my experience in software engineering spanning over 10 years to articulate my vision in this concise and well-structured format. In the end, our AI tools today can't read our minds just yet, so its effectiveness hinges on the quality of the requests that it is provided by people. So I definitely advocate to everyone, regardless of your role or discipline or where you are in your career, to invest time in learning framework to help you organize your thoughts, to help you create non-functional and functional requirements, ultimately to help create a project plan or scope of work that you would provide to the AI. Let's look at the user personas or type of users. Here you see the time I spent in truly immersing myself into the world of each user. For each user persona, I made note of what they care about. What is it that they want to accomplish? What does a good user experience look like for them? This is a tiny part, but an important foundation of design thinking. Truly knowing your end user and prioritizing their needs, desires, and experience. Which brings me to takeaway number 2. Invest time to learn about design thinking. With AI, the time to value will be reduced significantly. But as people, no matter your role or discipline, it will be more important to understand who, why, and how you plan on building things for. The next section to surface is the functional requirements one. The approach I use to write these is well known in the software industry and follows the following pattern. As a user persona or system, I want/need something so that my motivation. A simple but incredibly powerful approach to ensuring that everything built has a clean purpose and need. Upon expanding this section, you can see that I grouped the requirements based on the user persona. Feel free to pause the video here if you want to read through these. But for the sake of time, I'm going to continue moving forward. Let's go ahead and collapse these sections. Something worth noting is that in the technical requirements section, I noted that I wanted to use React.js for the front end, .NET for the backend, to have a relational database to store data, as well as the importance of the AI to adhere to engineering fundamentals like testing, security, observability, fault tolerance, and automation through continuous integration and deployment. In the key components section, I shared all the critical objects that would be involved in this solution, where each object has certain properties and relationships between each other. Things like a property, a unit within a property, an application tied to a unit and a renter, a maintenance request submitted by a renter for a unit, a residence profile for a renter that has had a lease accepted. This is important because as an engineer, this helps me understand how to define my data model in the solution. Okay, enough. Let's interact with GitHub Copilot. Notice how at the bottom, I already have this configured in agent mode. I'll start by clicking on the Add Context option. If your file is placed in the default place where GitHub Copilot looks for prompts, you'll see your prompt as an option. By default, it needs to be in the .github/prompts folder. With the prompt selected, I don't need to type anything else into the field because my prompt has everything already inside of it. Of course, if your prompt is more generalized, you can type additional content here before submitting it to the agent. But let's submit this as is. Now, throughout this entire video, I have edited things so that we wait the bare minimum for the response. In my experience using GitHub Copilot, sometimes the agent took up towards 2 to 3 minutes to respond. It won't always be as fast as you see it in this video. Right off the bat, the AI is basically telling me about the file and what it's reading and how it's comprehending it. This is called producing a chain of thought, which is a great way to follow along the AI through each step of what it plans to do and as it does it. For example, it tells me that after reading the file, it first needs to create a project structure for both the front end and the back end. And what's cool is that as an agent, it knows what terminal commands to run to do so. But before it simply runs the command, it asks you whether you want to continue or not with it. The command looks good to me, so I'm going to go ahead and press continue. But if you don't know what the command is going to do, don't just tell the AI to execute it. Use it as an opportunity to learn about the command first. The AI agent says it's run the command and puts a green check mark next to it. But let's take a look at this. This is a clear example of where AI needs a little bit of support, because even though it successfully did execute the command actually failed. This, I believe, is an opportunity to improve the AI such that it actually receives an indication for whether the command ran without issues. But for now, I know what the issue is, and I'll do my part to help it out to run the commands to create both folders. Goes without saying, if you've never worked in a terminal, you'll definitely be pretty stuck here for a while. AI doesn't replace the domain expertise surrounding programming yet. Now that I've created both of these directories, I'm going to tell it to continue. It looks like next it wants to create the Create React App frontend using a TypeScript template, which is great because in the prompt, I told it that's what I wanted. I'm going to go ahead and say yes. Go ahead and proceed running this command and installing the entire Create React Apps framework. Notice all of the warnings are coming up though. The terminal even reveals that the Create React App is deprecated. Why the AI agent used a deprecated package is unknown to me, but goes to show the importance of being in the driver's seat when using these AI tools. One should not use deprecated packages or dependencies as it would introduce potential security vulnerabilities. But for the purpose of this video, I'm going to move forward with it. I would expect in future iterations, as the AI becomes more intelligent and capable, that it would be able to reason and only bring in dependencies that are up to date and avoid those with known security vulnerabilities. It looks like the AI agent will now stamp out a new ASP.NET Core Web API project. Like before, the AI agent tells you what command it wants to run, which allowed me to confirm what type of .NET template it was going to use. Now that it's initialized both projects for the front end and the back end, it wants to now go ahead and set up some GitHub actions for CI/CD, continuous integration and continuous deployment, operations, and the dev container. If you're not familiar with these terms, I recommend to make note of them and do some research on them. In the prompt, I intentionally told the agent that I wanted to use GitHub Actions. But of course, you can provide it with any other CI/CD tooling preference. Here is the dev container I created, and I now have the chance to review it and make sure I'm happy with it. For the purpose of this video, I'll simply accept it for now. As you can see, whenever the agent produces a file or a change for your review, you'll see this blue bar that helps you navigate through the changes and determine whether to keep them or undo them. Taking a look at the AI chat, it looks like it'll begin looking through the backend code and begin creating the models for this solution. We'll let it run in the background while we review the CI/CD file inside the .github/workflows directory. This, for the most part, looks pretty standard. It's telling me when the actions are going to take place, which in this case are on push commits or on pull requests. It's using an Ubuntu image to perform all typical operations, checking out the code, setting up the .NET environment with a particular version, building the backend, running the backend unit tests, and then setting up Node to then be able to install the front-end dependencies, build the front end, run the front-end unit tests, and ultimately build a Docker image of the solution and push that Docker image to a registry. So overall, the scaffolding looks good for now. The Copilot is now going to set up the backend project, and then it looks like it will define the models, controllers, and services. This three-layered pattern is common with backend development, where the controller has no business logic, but serves as the API layer. The service layer has the business logic that the controller layer uses, and the models layer is the one that connects the service layer with the data layer. The agent is asking if I want to create the models directory, which I'll say, yes, please. We can see that new directory there. Looks like it's taking time to think about what changes to perform next. This area tracks and shows all the files that have been changed throughout the active Copilot session. It looks like it's created the property model, and it's going to then create a unit, application, maintenance request, and resident setup set of models. Let's look at the property model. At an initial glance, this looks like a good place to start. We see the address, description, square footage, all variables associated with a property. Fast forward to the point where Copilot finished creating all four models. You'll see this blue bar with controls to navigate through the changes. Here we see it say that there are 4 changes to review with options to keep, undo, or navigate up and down between the changes. I would normally be reviewing each change in real time as the Copilot is working behind the scenes, and take my time in making sure that I first understand the changes as well as judge its quality. This is where I'll raise a point. AI will not replace deep domain expertise anytime soon. In this example, my experience as a software engineer is instrumental in ensuring that every character, every word generated by AI is of quality, secure, and appropriate. But for this video, I'm going to skip over the review and just accept the changes. Real quick, if you're finding this video valuable, please take a few seconds to like the video and comment what you like about it so far, or ask any follow-up questions throughout the video. Okay, it looks like now it wants to create the necessary controllers to stamp out the APIs to interact with these models. As you see here, it will start with a basic set of actions called CRUD, which stands for create, read, update, and delete. It's going to start with a property controller, then move on to the unit controller, applications controller, maintenance request controller, and resident setup controller. While Copilot is thinking, I'll just quickly review the changes done to date, and for the purpose of this video, just accept them as is. Let's briefly look at the structure of one of these controllers. Near the top, we can see the root API path using the form API / the name of the controller. Initially, it looks like Copilot is using built-in memory to store a list of properties. Obviously, this is just a starting point. In future iterations, we definitely need to leverage a database to persist the data. Then we have various methods with the HTTP operations and API parameters to perform the create, read, update, or delete operations. Doesn't look like there is any security in the form of authentication or authorization for these APIs just yet, however. I'd call this a simple, yet effective good starting point. However, I also hope that at some point, Copilot iterates through here and reduces the business logic in the controller layer and moves it out into a separate service layer, leveraging dependency injection to configure the solution. If you're not sure what that means, yet another reason why domain expertise is so important. This actually brings me to the next key takeaway. When using Copilot, as you are reviewing the code and the content it generates, you will find things that need to be changed in the future, potentially even technical debt. So don't feel like you have to make those changes right away. Instead, I recommend writing those things down to help you and your team by informing the backlog or the list of things that need to be done before calling a particular effort finished. Writing things down will also help by providing a pulse check on how much technical debt one has endured. You do not want to let that get out of hand. You can see here on the right, Copilot is saying, hey, I've been working on this for a while, and would you want me to continue iterating on the request? This is pretty cool. Maybe I asked it to do too much in that 160 plus line prompt, and instead should have broken it down into smaller, more focused prompts. More on that later. For the time being, I'm going to tell it to continue iterating. Copilot seamlessly picks up right where it left off and is continuing its business. Okay, so let's see here. Next up, it looks like it wants to create a service in the front end to handle API requests. So now it's changing focus over to the front end, and it wants to create a new directory with an initial file named API service.tsx. So it's already thinking about centralizing the interface between the front end and the backend APIs, which is great. I like that approach as well. Before continuing, to recap, what we have on the backend are a set of models, controllers, configuration files, and the typical files like the program.cs and startup.cs files. The weather forecast file is left over from the .NET template Copilot used, so that file needs to get deleted. This is a very, very good start, and it was stamped out much faster than I could have done myself. Before continuing, I'll press done first. Whoa. Crap. Looks like pressing done terminated the current session with Copilot. I didn't know that was going to happen, which made me feel pretty anxious at first. But then I said, let's try to provide to the agent the same prompt as before and see what happens. Now that we have an existing starting point, how will Copilot behave? So looks like it's telling me it wants to break down all the tasks to the various steps, which is awesome. A total of 7 steps. And then it tells me in more detail what it wants to do with each step. I like this chain of thought articulation that the AI does because it's a great way to learn along with the AI. If there is anything that you aren't familiar with, you can make note of it and then ask Copilot using the chat mode to learn more about it, expediting your learning experience all directly within VS Code. One of Copilot's articulated steps is to create the interface between the backend and a database, which it plans on doing using a database context file. And then through dependency injection, this context or configuration can then be injected into the controller and or the services. And then it is recognizing that it's already got backend services for the models and the controllers, which is pretty neat. Copilot then wants to ensure that the backend service meets the requirements that I provided to it inside of the prompt file. Some of the requirements I told it was that the solution needed to have engineering fundamentals such as authentication and authorization, logging and monitoring, error handling, unit tests, and documentation. The first step Copilot wants to do is bring in a dependency called Entity Framework Core into this project, configure the database, and update the models to include those relationships and to go ahead and create migrations and update the database. More on this shortly. It also wants to bring in another library called ASP.NET Core Identity to enable authentication and authorization, followed by using Serilog for logging and Azure Application Insights for monitoring. Lastly, it's going to use XUnit for unit tests and create documentation such as a Swagger file to document the APIs. Wow, it wants to do a lot, folks. Okay, so now it looks like it's actually starting to make those changes. What's cool about Copilot editing existing files is this animation, where it shows it reading the file and then making changes by highlighting in green any additions or highlighting in red for any removals. And on the right side, it summarizes how many lines were added or removed. Here we can see it wanting to add the necessary dependencies to support ORM database management. To do so, Copilot also generated this DB context file, where each table in the database is defined here as a DB set type, implementing the respective model type that were created earlier. Copilot then begins changing the startup.cs file, starting by adding the entity framework core dependencies and models that were created earlier, followed by adding the DB context to the service collection variable. It also updated the app settings file so that the SQL Server database connection string can be defined as an environment variable. I'll just accept all of these changes for the purpose of this video. It looks like next, Copilot wants to update the models to include all of the relationships between each other. Things like ensuring that a unit belongs to a property, or that a property can have a collection of units or a list of them, or that a unit has a collection of applications, has a collection of maintenance requests, and that an application must be tied to one unit. So all of these relationships that Copilot was able to understand and know how to create in code, all using natural language for my prompt. Very, very cool stuff. Now with the models updated, Copilot wants to use the entity framework dependency it installed earlier to create migrations and update the database schema based on what we have now. Migrations is how changes to the database schema can evolve over time alongside the code. Here, Copilot wants to run the .NET EF migrations add command to create that initial migrations file, which will perform the database operations to apply the intended changes. It's these migrations files that allows applying and reverting changes to the database schema using the update command as shown here. Oh my goodness, but look at that. Copilot once again knows what it wants to do, but because the environment hasn't installed and set up .NET EF migrations, it failed to execute it successfully. So I'm going to help Copilot out by installing it before we continue moving forward. This is yet another example where it's important as engineers to understand what libraries and tools are being utilized when building a solution, so that if you need to configure them, install them, you know how to do so. So I'm going to fast forward to the point where I've installed and set up .NET EF migrations. From this view, you can see a successful output after running the .NET build command, as well as me running the .NET migrations update command. This created the initial create file, which is essentially going to run a lot of database table creation commands. This makes sense because it's our first migration file. Normally, I'd closely review this file, but for this exercise, I'll just let Copilot run the update command shown here. While that runs, we can see that Copilot now wants to implement authentication and authorization using ASP.NET Core Identity. And it tells me exactly what it's going to do to accomplish that. Looks like on our terminal, the build has now succeeded. Awesome. Copilot is now updating the backend.cs files to add the necessary dependencies to our .NET project. You can see here the two it wants to add. I would, again, as an engineer, before accepting the change, I'd make sure that the versions are what I want them to be. But for now, I'm going to go ahead and just accept the changes. Next, Copilot is changing the startup.cs file to create roles to support authorization, which will allow us to secure the APIs as defined by the controller files. Looks like Copilot has determined that this is the only change that needs to be done. Interesting. Copilot then wants to create yet another migrations file. This is strange because we didn't really make any changes to the models, so I wouldn't expect there to be a need to create a new migration file. But just out of curiosity, I'll tell Copilot to proceed with the creation of another migration. Fast forwarding past the time it takes for the command to complete, let's now look at the created migration file. And to no surprise, there's nothing there. A minor mistake from Copilot, but again, another indication of why it's important to understand what is taking place so that you can catch and prevent Copilot from doing things that don't make sense. For now, I'll just keep this here and continue seeing what Copilot does next. Okay, now it wants to first add rule-based authentication. Second, define the roles. And third, update the controllers based on those roles. I'm going to fast forward to where Copilot starts editing the startup.cs file. Look at all that code it just added. It is calling a new method called create roles and passing it to the service provider. Makes sense. Effectively, it gets an instance of the service provider's role manager and uses it to check if all the required roles exist. For those that don't, it creates them. Reading through what Copilot wants to do next, it looks like it's going to go through every controller. And based on my requirements provided in the prompt file, it's going to use its best judgment to define which roles are allowed to interact with various APIs. So I'll go ahead and accept the changes in the startup file. Here's another one of those Copilot prompts telling me, hey, I've been working for a while here. Do you want to continue? Absolutely. We're not done yet here, folks. Okay, so now it's editing the properties controller. Let's wait for it to finish editing the file. Oh, wait a second. It returned an error. Your request failed. Please try again. It gives me a request ID and it looks like it got a 408 request timeout. When this happens, you have the option to retry using this icon. I prefer doing this because unlike the other options of clicking done or starting a new session, retrying doesn't lose the context or anything that we've done so far. So after clicking on retry, looks like it's going to try rereading this file again, and let's see if this time around it actually produces some changes. Okay, looks like it did. Let's walk through the changes. It first added the ASP.NET Core authorization library that we installed earlier. And then for each API method, it's telling us which roles are allowed to perform them. I'll speed through these changes and accept them all. But I'll use this as an example that although Copilot did a good job for the most part, there were some roles that I didn't agree should be allowed to do certain actions. For example, the ability to create a property or delete a property. Both of these should just be something a homeowner can do, not property managers. But some of the other actions like updating a property, I agree that a property manager can do that as well. All right, let's go over to the applications controller next. Similar changes as the other controller. Take a look at the get applications method. Copilot has this as something a homeowner, property manager, or renter can do. But there is no business logic here that actually determines what applications to return. It just returns all of them. That's not what we want. This brings us to the next takeaway. As you see Copilot make edits, if you see something that needs to be improved, but is out of scope of the immediate work item or user story you're working on, think about whether it's worth making the change now or whether you should make a note to yourself or update the team's backlog. For this example, I would tell the team that we would need to revisit this method to enhance it so that only the applications that belong to the user are returned. If you are a homeowner or a property manager, you should get all the applications for the units associated to the properties you own or manage. If you are a renter, you can only see the applications you submitted. I'm going to fast forward to the point where Copilot finished making all the API role authorization changes. In total, it made 6 file changes so far. You can see that by seeing this 1 of 6 text here. I'll just select keep on all of these for the purpose of this demonstration. It looks like Copilot has successfully updated all controllers. Now it wants to add logging, monitoring, and error handling. It tells me it wants to add Serolog. That's all good stuff. It also tells me all the packages it wants to add to support this change. So the first thing it's going to do is update the backend.cs file like it's done before and add 3 new packages. I'll go ahead and just accept these as is for this demonstration. Now it wants to configure Serolog and Application Insights, a Microsoft Azure service so that they can be used in the project. We can see Copilot open the file, read through it, and apply the changes it wants to. And there is the logger configuration type it's instantiated, followed up with adding the Application Insights telemetry configuration to the service collector, and finishing up this file by ensuring that the API can handle an unhandled exception by returning the content found in the /home/error path, as well as to tell the app to use Serolog request logging at the bottom here. And based on the chat on the right, it looks like after it finishes here, it's going to jump right into implementing the unit test using XUnit, which is phenomenal. The first thing Copilot wants to do is update the backend.cs project to include the necessary packages. We can see them here, and for this exercise, I'll just accept them as is. Copilot then tells us that it wants to run this command to create the new test project. I'll let it continue running this command in the terminal. Fast forwarding, once the new project is created, Copilot says it needs to add some references to the backend.tests.cs project. This is a good way to keep dependencies clean. Our actual service doesn't need any of these packages. It would just become bloated. So that's why Copilot created two different projects, each with the dependencies it needs. One being the actual backend solution, and the other being the backend test project. It's adding XUnit, mock for mocking objects and behavior, MVC testing, and the .NET Test SDK. And based on what Copilot is telling me it wants to do next, it will create unit tests for each controller. Let's keep all these changes and fast forward to when Copilot created the unit test files. I will only review one unit test file, as the others will effectively perform the same approach. Let's open up the properties controller test. This is a good file name because it follows a common convention, which is to name the file based on the module under test, which in this case is the properties controller. Copilot also followed a well-known pattern of naming each test case using the name of the method under test, followed by an underscore and a short description of the scenario that the test is performing. Looking inside this one test case, it also follows a common structure of AAA. No, not the car service. AAA stands for arrange, act, and assert. Arrange is where we set up any specific dependencies or inputs for the module under test. Then act, where the module under test is executed. And lastly, assert, where we ensure the outputs are what is expected, whether that is good expected behavior or failed or error expected behavior, also known as the happy path or the failure path. As we see here, Copilot created a total of 5 unit test files, saving me a ton of time starting things up. Of course, there is very minimal business logic, so one could mention that doing this early on is not optimal. But some may prefer to take the stance of test-driven development, or TDD, or behavior-driven development, BDD, where one first writes the test, causing them to fail until the business logic is implemented, causing them to pass. Something which I recommend you to try out using Copilot. But for now, let's accept the current unit test bed and have Copilot continue. Looks like next it wants to work on containerizing the solution based on the technical requirement I provided to it in the prompt. This makes the solution much more portable, a huge benefit. Copilot proceeds to tell us that it will create a Docker file for both backend and a frontend and make sure that the solution can be built using Docker. This is great. It's exactly what I wanted to do. I want both my solutions to be developed and deployed independently of one another. Sure, it goes without saying that the front end and back end need a mutual agreement or contract that's provided by the APIs. But the underlying logic can evolve independently over time without breaking the front end by leveraging API versions, URL versions, or other similar approaches. But we won't get into all that in this video here. Let's review the Docker file that Copilot created for the backend. It copies the necessary files, builds the project, and provides the port and command to run the image as a container. To save time, I'll just accept this as is. Next, Copilot mentions that it wants to create the Docker file for the front end, and it asks me, hey, I've been working a lot here. Should I continue? Yes, please, let's continue. Let's review the Docker file it produced. It copies the package.json file where all dependencies are defined in, installs them using npm, builds the front-end solution, installs the Nginx image to serve up the front end, exposes port 80, and then defines the command to run the Nginx web server. Copilot then logically articulates that it wants to build both Docker images and run them as containers to make sure that things are working. Copilot provides the command it wants to run and asks me to run them. But here's the thing. I'm using a pretty old laptop here, which doesn't have Docker installed, hence why we see the error here. So I'm going to press cancel and save all the files and tell Copilot that I'm done with this session. But there's still a lot more that I expected Copilot to do based on the prompt I provided. So like before, all I'll do is provide it the same prompt and ask Copilot to run again. It's a brand new context window. It's reading the prompt, telling me what it wants to do, and it looks pretty similar to what it's provided to me in the past before. It talks about the backend, talks about the front end, authorization, authentication, deployment. Here, it looks like it wants to make some changes to the CI/CD that we had before, which is curious. Let's read through and see what it's going to produce. I'm not seeing a lot of actual changes. It kind of just changed the syntax by removing the working directory portion and instead opted to run a cd or change directory command. Oh, cool. I take that back. Copilot recognized that we had a new project for the backend unit test and updated the section to ensure that they run and pass. The front end looks similar as well. Copilot removed the working directory and instead cd'd into it. It runs an npm install and build command, as well as runs the unit test in the front end. And lastly, Copilot also recognized that the front end and back end are now two separate images. So in order to build the images and publish or register them, Copilot made the necessary changes. Let's take a look at what Copilot is telling us it wants to do next. It wants to define the database schema, implement secure REST APIs, add unit tests and documentation. But we already did a lot of that, so I'll be curious to see how Copilot reacts once it notices that. It does convey that it noticed that the models already support the database schema, but it still wants to proceed with implementing the necessary controller services, which we have already done. But let's let it do its thing and see what it decides to do. Okay, I see what it's doing now. Okay. So in the past, like I said, there really wasn't any connection with the controllers and the database. But now, Copilot's using dependency injection by bringing in the database context and then replacing not just returning the applications model, but returning the database-specific application table information back to the requester. But still, there is a lot of business logic that is missing, such as when getting applications, even if the user is authenticated, they are not authorized to view all applications, only the ones that are associated with them. If the user is a homeowner or a property manager, then they get to see all applications from the properties they own or manage. But if the user is a renter, they can only see the applications they submitted. As I continue seeing the changes Copilot made, simply by adding the database context injection, we are able to reduce the number of lines significantly, such as in the update application API method. Copilot does a sanity check to ensure that the ID of the application being updated matches with the updated application object. And if it doesn't, it returns a bad request. Copilot will proceed to make these same changes across all the other controllers. I'll fast forward through all of this. Again, normally I would review these changes much more rigorously, but for now, I'll just keep all of these as is. Like before, at some point I got this error again. So once again, I simply just press retry to have Copilot pick itself back up. This looks wrong. It looks as if Copilot got confused here. It decided to add content into my prompt file, which isn't even part of the solution. Based on the content it's adding, this appears more relevant for a README, not the prompt file. So what I would have done here is copied all of this and I would have moved it to a readme.md file instead. So I'm going to undo what Copilot has done. You can do that in one of two ways, either by clicking the undo button here or the undo icon here. Once I do that, I'll restart a new Copilot agent session and continue on with building our solution. I hope that this time we get to more of the business logic, or that Copilot starts building out the front-end solution some more. We'll see. Let's look at what Copilot is planning on doing. High-level tasks. It talks about the backend, the front-end, containerization, CI/CD, dev containers, relational database. It also mentions that the solution must adhere to the technical requirements and functional requirements I've provided. It then tells me what it wants to do, all very similar to what we've seen before. Nothing new here. I'm going to skip right to the part where Copilot began working on the front end. Here, Copilot is telling me that it wants to ensure that the front end meets the requirements and has documentation. To do so, it'll start by reviewing this file I have open here, which is the entry point to the React.js applications. This is cool. Copilot basically explains what this file represents in its current state and identifies that the file doesn't have any of the integration with the backend APIs we wrote. Next, Copilot tells me what it wants to do, starting with creating the React components and services needed to integrate with the backend, and that it wants to use this app.tsx file to handle routing between the different React components. That's where it's going to start. It looks like it wants to create a component for managing properties. So it will create a properties.tsx file to implement calling the APIs and also render the list of properties and allow the user to create, update, or delete them. Here's a file it created. If you're not familiar with React.js, again, the purpose of this video is not to go deep into that, but let's cover some of the basics. Copilot starts by defining the property interface, which is effectively what it will get back from the backend API. It then stamps out some of the syntax to store the list of properties it has in state/memory, along with the methods to set or update that state. On line 21, Copilot wrote a fetch properties method, which calls the /API/properties API. It added a try catch for basic error handling, such that if it errors out, it'll log an error to the console. It also wrote a method to handle input changes. Anytime there's a change to the DOM by the user on the browser, it will reflect that. It also wrote a method to handle the ability to add a property and a method to handle the ability to delete. Again, I would make a note to myself or in the backlog that my team owns that the front end, similar to the back end, needs to have both authentication and authorization, such that only homeowners are shown the abilities to perform some of these operations, while the property managers are shown less and the renters are shown even less actions that they can perform. And here's the actual HTML in the DOM that has the various ordered lists and unordered lists with the elements that we can interact with in the front end, such as the button to add a new property, a field to enter the address, a description, the total square footage, total number of bathrooms, all of that goodness. So that's all the properties portion. And now Copilot wants to go ahead and bring in that properties component file into the app.tsx file to support routing to it. Here are the changes Copilot has made. It changed the page title to rental solution, and it added the changes necessary to support routing from the home page to the other pages. For now, it supports routing to the properties component we recently defined, as well as the main page, which is the default route. I'll go ahead and accept the changes and see what Copilot does next. It appears it will continue building out each component for the other APIs and then change the app.tsx file to enable routing to each component. I'll fast forward through all these changes to the point where it finished creating all components. With all components created and with routing supported to them from the main page, Copilot now wants to create this file called apiservice.tsx. The file basically serves as a wrapper to encapsulate in a single place the Axios HTTP methods. This is a strategy to efficiently handle any overhead involved in crafting up an HTTPS request, such as header values. It also helps with unit testing, given it makes it easier to mock up HTTP requests by mocking the API service file and not the underlying Axios library. Looks like Copilot will now update all of the components to use this new service. Here's one example of the way that looks. It removes the Axios dependency and now just calls the API service get method and uses the results to set the properties for this component. Copilot will do this for all other components, which we'll fast forward through. Once all changes are done, Copilot moves on to create this README file for documentation. It documents about the structure of a solution, how to get up and running, how to build and package it up, talks about the CI/CD, and a high-level description for the overall usage of the solution. This documentation is all helpful when trying to get the solution running locally or on the cloud. I'll go ahead and close all of these files and tell Copilot agent to stop iterating further. What I noticed at this point was that everything we have accomplished is fantastic, and it definitely has saved me a ton of time. But based on the functional requirements I outlined in the prompt file, Copilot agent failed to actually implement them. This brings me to my next key takeaway. When coming up with your prompt, avoid using prompts that span too many domains. Some example of domains include the solution goals and objectives, a description of the user personas and their motivations, the non-functional requirements such as what tech stack to use, initializing the project, and then each of the functional requirements by itself. I recommend coming up with a separate prompt file for each of these domains, and for the functional requirements, to draft a prompt file for each requirement, such that each one can cover what we typically see in a backlog work item or user story. This approach actually mirrors what we typically do on a product team, working as a team to build a solution piece by piece over time, not done all at once. This, I believe, will also benefit more in maximizing the power of Copilot agent mode, in the form that per functional requirement, you can reason and iterate with the Copilot to collectively design, implement, test, deploy, and validate that the behavior done is what is desired. What I'll do for now is go through an example of writing a functional requirement to see how Copilot in agent mode handles it. My first request to Copilot is to update the backend so that the homeowner can have the ability to assign a property manager to a particular property, and that only assigned property managers can perform actions on those properties. My hope here is that Copilot will be able to recognize what we built in the backend and front end and know which files it needs to update. Let's go ahead and submit this request. It looks like Copilot will start with the model layer. Copilot adds a variable called property manager ID to the properties model. It then tells me that it wants to update the properties controller, then the units controller. As we can see, here's the API that allows a homeowner to assign a property manager to a given property. Over to the units controller. Copilot says that it needs to make changes such that only a homeowner or property manager can create, update, or delete a unit. Copilot adds a static variable that holds a list of properties. Okay, that's strange. And we can now see that create unit method appears to be checking that the user making the request is authorized to create a unit. And if they aren't, it returns an HTTP forbidden response, which is what we want. But the implementation is flawed. Line 37 should be getting the property ID from the user making the request to create a unit for a given property. So in real life, I would revert these changes and help Copilot make changes to the model layer first, or to change the API such that the URL is a post command / property ID / unit, so that the requester must provide the property ID when creating a unit. With this approach, the business logic would be able to better check if the requester is authorized to create a unit for that given property. But let's continue for this exercise. In reality, as a homeowner, I may want to have multiple property managers per property just to have resiliency in the case one of them goes on vacation or what have you. So I tell Copilot to help me make those changes. First thing it does is make changes to the properties model so that instead of having one property manager, the variable type is now a collection or list. Next, the Copilot is going to read the properties controller and make changes to support this new behavior, such as changing the HTTP URL so that a requester can notice that it can provide a list of property managers to the property. Let's see what changes Copilot made to the units controller. Looking at the changes, it appears that all Copilot determined necessary was to change the names of some variables and the isAuthorized method to handle a list of property managers instead of just one. For the purpose of this exercise, I'll accept and keep these changes. It's worth noting at this point that I'm not loving having this much business logic in the controller layer. I'd really like to abstract that out into a service layer, something I would make a note or add as a backlog item to ask Copilot to help me refactor later. But for this exercise, I'll ask Copilot to help me update the unit test based on the changes we've done so far. After Copilot takes some time to think about it, it produced one new test case for the properties controller module, and specifically for the assign managers to property method, which appears to test a basic path, but it's missing many edge cases, which in my opinion is where unit tests offer the most value. I would have liked to see scenarios like a property manager not affiliated with a property wanting to create or delete a unit, or to try to create a unit for a property that doesn't exist. So I think Copilot has a lot of room for improvement here. Or maybe I need to improve my prompt to tell it to consider edge case scenarios and test for exceptions and error handling scenarios. The last request I have for Copilot agent mode is for it to help me implement these requirements involving a contract. As you can see, as I'm highlighting the text, the context window shows that it would include the highlighted lines as context. In theory, I could just ask it from here to help me implement the highlighted requirements. But instead, I'll copy the text, add the entire code base as context, ask it to make changes to enable the below requirements, and then paste the requirements. I'll submit this to Copilot. Like before, Copilot will scan the entire solution to create a plan on what changes across all the necessary files it needs to make to support fulfilling the request. An example of the Copilot agent demonstrating knowledge, reasoning, and ultimately action. Looks like it wants to make changes to create a new model, update the maintenance request model, add a new controller for managing contractors, update the maintenance request controller, and update the database context to account for the new contractor model. And look at this, it even identified a need to update the front end, such that it creates a contractor React.js component and updates the maintenance request component. I really do love how easy it is to understand and follow along with what Copilot wants to do. I just noticed this behavior. It appears that Copilot first outputs its plan, and then it almost repeats its plan verbatim, but now specifies which files it plans on changing. I'll fast forward through this reasoning as it's just repeating what it already told us it was planning on doing. It now says it'll start by implementing these changes. It first starts with creating a contractor model. I won't spend time reviewing this and will just accept the changes. Next is a change to the maintenance request model, such that it now accounts that it can be assigned to a contractor. Same thing, we'll just accept these changes. Next, the addition to the application DB context file, so it knows that there is a table called contractors. We'll also accept this change. Copilot then created this contractors controller with some API methods. Excellent. I'll accept this file as is and have Copilot move on next to changing the maintenance request controller. Here we can see Copilot added a couple new API methods. One where only a contractor can update the contractor details with their notes, invoices, or any images of the work done. This is missing a conditional check such that the contractor making this request must be the one that is assigned to the maintenance request. A check that I will note down or add to the backlog so we can introduce it later. There's also an API that allows a contractor to get the available dates pertaining to a maintenance request. Similar, this is missing the capability for the contractor to propose a different date or to accept one of the available dates. I'm going to jump real quick over to the unit tests that Copilot generated for this request. The first test case is a basic one, the ability to create a contractor. The next test case is the ability to return a contractor by expertise type. Again, I wish Copilot would produce more edge case test scenarios, such as what happens if a work type isn't supported. Okay, I'll accept this change for now and move over to the unit tests for the maintenance request controller. One test case was generated for updating a request with contractor details and another test for returning the available dates given a maintenance request. Okay, with the backend changes done, I'm going to jump right to where I saw Copilot begin making changes to the front end for this request. Here is the contractor component that Copilot created. Like before, it first defines the interface which contains the properties that we would get back from the backend API, along with the fetch contractors method and handler methods for adding and deleting a contract. The next file Copilot changes is the maintenance request front end component, where we can see the addition of the contractor ID, contractor arrival dates, contractor notes, invoice, and receipt in the interface block. All right, that's all I'm going to show when it comes to interacting with Copilot. So let me summarize some of the key learnings and tips for you to consider when working with Copilot in agent mode. Let's start by saying that Copilot is a very early product, but its impact in the long term will be a game changer. No doubt about it. My first tip is targeted for current software engineers or those interested in becoming one. You must learn to be comfortable in exploring and using these AI tools to not only augment your productivity, but to also expedite your ability to learn and augment your ability to ideate on designs. Ultimately, these AI tools are a force multiplier, but they won't fully automate everything. You still need to gain breadth and depth when it comes to a domain, but there's no reason not to try this out. GitHub Copilot is free for everyone, and it's only $10 a month to get unlimited interactions to its most valuable features. Next, what do I think makes Copilot agent mode special over, say, chat mode? First, code-based search. It searches your entire codebase to find relevant files without you explicitly specifying them, as we saw in my demonstration. Next, self-iteration. It can iterate on its own output to complete your entire request in one go. We saw that as well. Third, error identification and repair. It automatically recognizes and fixes errors in suggested code. Here, we notice that it itself can produce errors though, so be sure to always check its work. Fourth, terminal command execution. It suggests and runs terminal commands with your permission, as we saw in this example. Fifth, build and run capabilities. It can build and run your application to check if changes work correctly. I didn't take advantage of this due to my limited environment that I was working in. When do I envision myself and leveraging GitHub Copilot in agent mode? First, when building complete features. You saw me do this when I was telling Copilot to implement individual features one by one to an existing code base. Second, navigating unfamiliar code bases. An example such as, help me understand how authentication works in this project. Copilot is very good at taking a lot of information and being able to answer specific questions. Third, writing and verifying tests. This one, like we saw, it just needs work, and I'm going to need to continue practicing and making sure that Copilot can produce edge case scenarios when writing unit tests. Fourth, implementing terminal heavy tasks. We saw this in action. I didn't really need to spend a lot of cognitive currency to think about all of the commands I had to run. I just told Copilot to do it, and I double checked that the commands it produced were the ones that I felt were appropriate. Next, doing complex refactoring for what may seem like a simple change. This is also really helpful because I no longer have to keep track of potentially all the different files I have to change to make one particular change. Copilot is going to have the awareness to do that for me. So to wrap things up, folks, now is the time to embrace and be comfortable with change, more so than ever. Now is the time to embrace a growth mindset and really get curious on how you can use these AI tools to your benefit, no matter what line of work you're in. I hope that you found this useful. And if you did, please be sure to like it and share it with your social circle across all platforms. Also, subscribe to not miss out on future AI content, along with the other topics that I am passionate around, such as homeownership, real estate, or DIY do-it-yourself maintenance, repairs, and renovation projects. Thank you for tuning in, and till next time.